This is the supplementary material for function and relations, especially discussing about function, domain, and range. Okay, so let's go to this visual. So yeah, it's very common in the internet. If you use a function set, when you Google it, you will come up with this picture. Since the inputs are the raw materials, when you put into a function machine, the outputs will be the product. The inputs are the independent variables. So usually we use X. So all X, or all the inputs after being processed by the function fx of machine, the output are all the Y values, the product. So when you put into your machine all of the raw materials, so the bucket that contains all possible raw materials that will be produced is the domain. Okay, so all X that is used to solve for your equation, for your function, all X must be contained in your domain. And all the products, all the outputs that comes out from your machine will be in the range bucket. So the range must define or must describes all possible outputs, all possible outcomes of the function machine. In the graphing perspective, you can see that the domain is all values of X that is depicted by your graph. So you always use the perspective from left to right. Okay, what is the most left possible value of your X and the most right possible value of your X, and then you find all of the inside the domain is all X between of that border is included. So this blue line showing all possible values of your X that's being presented of the graph as your solutions. And all possible value of Y, you can see the perspective from bottom to top or top to bottom. So what is the maximum value of your Y and what is the lowest value of your Y as the border, and you have to check whether every value of Y in between are included on your graph. So this is the range. The independent variable usually using X and the dependent variable using Y. Therefore, we prefer using X for your horizontal axis and Y as your vertical axis. But again, it depends on our agreement. So if I use another kind of visual, when you have independent variables as your raw materials, usually it represents by X, but not necessarily X always. So when you put into the machine, all of the values from that buckets will be the domain. Okay, so if your solutions, imagine if your solutions show that there is a value of X that comes outside of the bucket, it means it is not intended to be processed as your product. Okay, so and the output of your Y, usually we call it dependent variable. Why it is dependent variable? Since the dependent variable is dependent to the independent variable. Okay, now this is another perspective of independent and dependent. So if it is being processed by a function, the raw material or the input will be independent variables. The output will be dependent variables. So when I put the color here, the purple is always the independent variables, the blue is always the dependent variable. Usually we use X and Y, but this is not necessarily a mandatory thing. So actually I can use the opposite. I use Y for independent. The most important thing is you know which one is independent, which one is dependent, since the dependent variable is dependent on the independent variable. So this is an example of how it works. For example, if my raw materials, I use 4, and then 4 comes into the machine, it's being processed, and then the output is F4. Okay, so actually this is how the algebra language speaks about. When you put 4 into the Fx, the output will become F4. For example, if the function or the Fx is for x plus 2, so if I put, the raw material is 0.5, which is the x, which is the domain, and from the domain, and then when it's processed, the output will be f of 0.5. So I was just substitute the x by half, and then I can see that the value of my f 0.5 is 4. Since if we speak f 0.5 is very long, it's very complicated, usually we exchange the f of 0.5 to becomes y to make it simpler. Okay, so if I put another input -3, and it is being processed by the function, the result is f of -3, or the y, which is -10. So if that's only all the materials that I process, if only I just process 0.5 and -3 and no other values of x then being processed, so the outcome will only 2 also. So this is how I write the domain and the range. The domain, or the bucket of my raw materials, consists of 0.5 and -3. The range, which is the bucket of my outputs, outcome, or final products, consists of 4 and -10. And if I show the relation between them, so the 0.5, the outcome will be 4. I use a straight line here. And -3, as its raw material, the product will be -10. Okay, this is how I show it in this term. So if I'm showing it in order pair, I'm using this form, 0.5, 4, and -3, -10. So the domain, if I'm stating in other form, it is put inside the braces, and then 0.5, and -3. This speaks about the domain. It means the domain must show all raw materials that you use to your function machine. Okay, and all the outputs you put inside the range. So -10 and 4 are the range. The solution, okay, the solution sets for all of this, if I'm only using 2 raw materials, 2 inputs, or 2 values of x, therefore I only have 2 solutions also, which is 2 ordered pairs, x and y. So you need to combine the x value with its pair, the y value, 0.5 with 4, -3 with -10. If I show you another example of function, for example, fx equals -x squared. So if for this one, I will try to process 3 values of x only, 3 values of x. So it is -2, 3, and 10. It means your domain only consists of 3 values. And when I process it by the function machine, okay, the output usually, let's just change the fx to becomes the y. The y, or the product, consists of also 3 values, -4, -9, and -100. So this is your range. So again, the range is really dependent on what is the function and what is the domain. Okay? Therefore, the solution sets for this function in response to the domain is, there are 3 solutions, which is, you can see on your on the bottom, and then you can see that if you have 3 raw products or raw materials, in the end you will have 3 products, and there are 3 solutions, although it doesn't work that way always for other cases. But this is for these specific cases, yes, we have this kind of situation. Or if I put the domain in braces consists of 3 values, -2, 3, and 10. And the range consists of 3 values, -4, -9, and -100. Now give me another example, the last examples, but different domain. So if I'm using the function or fx equals half of x squared, and the first domain that I use is, okay, let me just show you that. Let's just exchange the fx into y to make it easier. Okay, since the function of x, it's easier for us to replace with any variables. For this one, we use y as the dependent variable. The domain, so this time I want to process only 2 values. So your solution or your graph can only include these 2 x values, only 2, since the domain is only consists of -2 and 4. Therefore, if I put these 2 values into the function machine, okay, let's see the table, the y will be, the first x product will be 2, and the second x product will be 8. So I have the 2 pairs or 2 solutions, which is -2, 2 and 4, 8 that can satisfy the equation in the specified domain. If I'm showing in the graph, so the graph can only depict 2 dots only, since there are only 2 solutions, since there are only 2 pairs, since the domain only consists of 2 values, and the range eventually will consist of 2 values also, which is 2, 8. If I use the same function but different domain, for example, this time I used 7 values of x. Okay, before we have 2, but now we have 7, -3, -2, and so on. So if I put them into the function machine, okay, we have these pairs. Interestingly, the values of y is not the same. It's not 7 different values. Instead, it has 4 different values. So if I graph it like this, now this is the graph and only consists of 7 dots, 7 ordered pairs. That's all. So this graph really depicts and consistently the domain and the solution. Only 7 solutions, since the domains regulates you can only involve 7 values of x. The range itself will be 0. So let me just write it here. The range will be 0, 0.5, 2, and 4.5. So only 4 values for your y, although you have 7 values of your x. It means the range, again, must represent all possible values of your outcome based on the function that you use and based on the raw materials or the values of x that you put into. The next one, let's see, if the domain, I change it into integers, so all integers can be your solution. So let's find its pair to satisfy the equation. Since it is integers, of course, we have many members of your domain. So I will start with -6, but keep in mind that I can go further to -7, -8, and so on. And you can see that my table ends at 6 on the bottom, but it still can continue and it still can go on to 7, 8, and so on. But let me just, I am satisfied with this list. And when I graph it, it becomes like this. So it needs to be on dots, on closed circles, not being connected with a curve or a line. So actually, the dotted lines just showing you the pattern, what is the graph looks like. But again, what matters is the solutions are all the dots here. But keep in mind, there is a arrowhead on the edge, it means it's still continuously with the same pattern to the both sides. Okay, and then the last one, if I'm changing the domain for the same function into real numbers, this will be the graph. I connect all of this since all of the x values on this graph, on this curve, is included for your solutions. The domain are all real numbers, and it would be continuously go to the same pattern to both directions. So see the difference? With the same function, you can have different kind of graph. So the graph are the solutions that based on the function itself and the domain.